Example number 4, a beam of white light containing frequencies between 4 times 10 to the power 14 Hz and 7.9 times 10 to the power 14 Hz is incident on a sodium surface which has a work function of 2.28 electron volt. Okay, so now we have to calculate the threshold frequency, the range of frequencies in which this beam of light, the range of the frequency in which the electrons are ejected from the sodium surface, and lastly we have to determine the highest maximum kinetic energy that are ejected from the surface of the photoelectrons. Okay, so the work function is equal to 2.28 electron volts, so we have to multiply that with this value, so you will get around 3.65 times 10 negative 19 joule. Okay, so the threshold frequency is again just equal to this equation, so you will then get the threshold frequency to be equal to 5.51 times 10 to the power 14 Hertz. Okay, and then the range of frequencies that would allow the ejection of electrons is between 5.51 and 7.9 times 10 to the power 14 lah. So basically this one, the beam of white light that has this frequency would not be ejected lah. I mean the electrons would not be ejected from the surface because it does not meet with this threshold frequency. Okay, so that's why the minimum is this threshold. Tinggal pula. So the minimum value of frequency that would allow for an electron to be ejected is 5.51 times 10 to the power 14, and this one does not meet the threshold frequency. Okay, all right, so question C pula, the highest maximum kinetic energy is, we are gonna use the maximum frequency frequency of the radiation, so that is 7.9 times 10 to the power 14 Hertz. Okay, so that is the maximum frequency, so that is gonna tell us about the maximum kinetic energy. Okay, so again we are going to use the photoelectric Einstein photoelectric equation. So that is this, expand it, and then you get plus dengan the work function. So from here you would get the maximum kinetic energy to be equal to 1.59 times 10 negative 19 joule. Okay, so that is the solution for example number 4.